Okay, so now before you resume in your video lecture on the growth sample, so makakaroon tayo ng so-called derivation on the growth sample calculation. Although I will not be deriving on a very complicated scale because I believe that the BSChem curriculum does not have enough statistic subjects to warrant the full derivation of this equation. So, assume that we want to analyze a drug tablet. So, we have a simplifying assumption that it has two particles. So, the particle A is the active ingredient, hence is our analyte. And then you have your particle B, which is a filler material. So, hence is our matrix. So, nakalap na lahat ng mga uh, non-active ingredients, and so nakalap na lahat ng hindi mo target, hindi mo analyte sa particle B. So this simplifies your derivation. So let's assume that you have two probabilities. So the probability of finding particle A, P, A is equal to P, and then the probability of finding particle B is PB, which is equal to 1 minus P. So saan nanggaling yung 1 minus P? So ang probability lagi is equal to 0 to unity, which is 1. So kapag ang probability mo ng A ay P, so makukuha mo na agad yung probability ng D by subtracting the P into unity, which is your 1 minus P. So now, if you have n particles, if you take n particles, and then you can get the most probable number of A, so A NPN, by multiplying your probability of finding A, which is equal to P, by the number of particles. So likewise, you can obtain the most probable number for B by multiplying 1 minus P by N. So this is the total number of particles, so your N. So now, if you will obtain the relative standard deviation of your A, so you will have square root of NP multiplied by 1 minus P. So, dito sa equation na to, if we take it apart, part by part, so itong N is your number of particles, so P represents your particle A, and then 1 minus P represents your particle B. So kung mapapansin natin dito, ang representation ng relative standard deviation ay small letter sigma, if I'm correct. So hindi siya letter S kasi when you are having particles as your sample and having probability distributions, so you are handling a large number of particles. So it's not a sample standard deviation, it's a population standard deviation. So likewise, if you want to get the relative standard deviation, so represented here as sigma r, so it will be equal to the relative standard deviation of A over NP, which is equal to the square root of 1 minus P over NP. So, madali lang yan makuha. So, para makuha yan, so you have your relative standard deviation of A is equal to 1 NP, square root of NP multiplied by 1 minus P. So, over NP. So, pwede nating baguhin yung representation nito nasa taas as NP raised to 1 half multiplied by square root of 1 minus P over NP. So, makakancel lang ito nasa taas, and then mababawasan ito na 1 half. So, So, magiging 1 minus 1 half. So, magiging sagot mo ay square root of 1 over 1 minus p over np raised to the 1 half. So, which will be equal to square root of 1 minus p over np. Okay, so naintindihan naman kung paano derive yung equal, yung nasa equal sign. And then, if you rearrange this form, so the relative standard deviation of R is equal to square root of 1 minus p over np to get n, which is the number of particles. So makukuha mo yung n is equal to 1 minus p over over the relative standard deviation squared, so which is the variance times p. So ngayon, kinoconsider mo lang dito yung isang type ng particle, which is yung target mo lang, yung analyte mo lang. So now, if you want to get the number of particles, considering your B, so kailangan mo gamitin itong equation na to. So N is equal to P multiplied by 1 minus P times dA dB over D squared all over squared. So multiplied by PA minus PB over relative standard deviation of R multiplied by P squared. So dito sa equation na to, so mapapansin nyo, meron ka ng species A and then species B. And then, so dito, ang dA and dB represents the density of your A particles and B particles. So, be reminded na hindi siya derivative. So, siya ay density. And then, D squared is the average density. So, ipapakita ko sa problem later in another video on how to use these different densities. So then, itong equation na to sa number of particles, so para makuha mo yung relative standard deviation nila, so pwede mo magamit ito, sigma r is equal to PA minus PB, absolute value, over P, so times dA dB over D squared, multiplied by the square root of 1 minus P times P over N. So it's just simple equation rearrangement. So I believe that you can already do it. So now, meron kang constant na nagre-relate ng mass of your sample into the relative standard deviation. So kasi kapag naman ikaw ay nagsasample, so syempre, you are obtaining mass instead of the number of particles. So, para makuha yun, so meron kang Ks is equal to M multiplied by sigma R multiplied by 100 times squared. So, itong sigma R, so ito lang itong equation na to, and then, your Ks is your Ingamel's constant. Ingamel's constant. So, in the problem solving video, I will discuss how to use this constant. So, meron pa na ngayong relationship between your relative standard deviation, the mass of your sample, with your Ingamel's constant. So, makukuha mo na yung gross sample na mass na kailangan. So, I hope you understand this lecture. Thank you. And then you can now go back to your lecture on gross sample.